idea. Oh, we don't need that anymore. We don't need that. We don't need that. We don't need that. Hi. Hello. Good morning, everybody. This is gonna be funny. Okay. There we go. So, is it time? Yeah, it's time. Hi, hello, everybody. Welcome, welcome. Come in. We are about to have a really great time here. Enter, my friends. Enter. Fucking YouTube thumbnail. I don't know if I've shown anyone this before, but or this, when you first look at this, you think it's a bad picture, but that's just how it looks. It's so broken. Anyway, I'm gonna make this into like my starting soon screen, my starting now screen. This is going to be the thumbnail for every WDDM stream because this is pretty much exactly how it's gone. Oh, that is really funny. Anyway, so why are we doing this? What are we here for? Why am I streaming at 10 p.m.? These are all great questions that no one's asking. So, previously on ReactOS, should be a blue screen? No, because it's not blue screening, because I am great at this, all right? It is not blue screened once. I thought the thumbnail was low quality. No, bro, it just looks like that. That's the aftermath of... Okay, so that's the aftermath of one of the graphics cards dying from running our new video stack. That's what happened to it. That's why it doesn't work anymore. It just looks like that now. I've tried cooking it. I've tried like going through with my multimeter and finding where the dead chips are. Like half the RAM chips died once it tried to render something with DirectX. It was really funny. But that is like legitimately what happened. Ah, yes. So, you might be wondering why I brought you here today, everybody. I'm streaming on YouTube and Twitch this time. That's a first, kind of. Yeah. So, why am I doing this? Okay. I have been working for the last couple hours, like 3, and then more so yesterday, when I didn't work. And we got the native Vista DirectX kills GPUs. Somehow I've managed to create that situation. So, which is really, actually, technically, it's a compliment to my raw talent and how great I am. Yeah. Yeah. So, we've got stuff here. We've made tests. It renders a picture, a very, very intense picture, like one of the hardest, like, things to render ever. I just gotta find it. Hang on. Yeah. Boom. Boom. It's pink. WDDM, yes. This is the most intense application ever manufactured by the ReactOS committee of ReactOSing. And, yeah. So, yeah. Oops, that's not what I wanted. Oh, it's called native. I don't know why I give it the worst names, actually. So, if we run this application in Windows with WindyBig, WindyBoo, WindyWoo, we can see... No, you can't. Yeah, we can see that there is some text that appears after loading stuff, and it made its factory, and we can see that it discusses what render targets there are on the system. And so instead of using any of the fancy APIs, this creates a DirectX 10 screen with the power of the raw C exports, which is not how you're supposed to do it. This is actually incredibly wrong, but it is the lowest level we can get to, thereby giving the ability to do funny things. Funny things like writing an entire GPU architecture around trying to get this to work. So, we know that this present, the swap chain, is pretty much the only command that will work without a DirectX 10 scheduler. And so this is our only test of native DirectX that we can really do. The good news is that this is enough. The main reason we're doing this is because I want to be able to create just a quick test to see if OpenGL can eventually work. This is just simpler. And the reason for that simply comes down to this. These functions here, the enum adapters, essentially only directly loads a UMD. A UMD being the user mode component of a DirectX driver. So, that was weird. This will allow us to create the factory using basically just software, right? Actually, I think I can just show this. Hang on. We can probably just show this. So, without my WDDM stack being completely put into place, it's put into some places, we can watch at what point this actually fails, which is helpful. So let's see what happens when we just load the thing without the WDDM stack. There we go. If we do this, we can do that. Load, please. Thanks. Cool. Hey, buddy. How you doing? Okay, so now we can load this. And it gets really big for some reason. I don't know why I did that. That's kind of obnoxious. A spaz in chat. That's understandable and necessary. Okay, so if we call this function, we can actually see that DXGI makes its factory, and then, oh no, the thunks fail. And you were like, why do the thunks fail? And really, that is because this, dun dun dun, is broken without the ability to call anything. That's not entirely what we're fixing today, though. However, I think that's relevant to know. We have the KMT APIs in place, and so the DXGI from Vista actually loads, and 7 and 8. And as you can see from it creating its factory, we can actually start the process of initializing DirectX 10. It's just once it needs any kind of hardware is where it fails, which it makes sense. That's what would happen on Vista without a video driver. So, all in all, I could say we're doing pretty good. If we do this, we do that, and then that, and then that, and then we're going to do that. There's a lot of strange noises going on upstairs. They sound like they keep vacuuming or something, I'm not sure. Okay, so we can grab all these, and we have a bunch of other tests too, in case you were curious. Our goal is to run a couple of these, long-term goal anyway. Like, magical particles. Wow. Well, that didn't run. Oh, that didn't either. Okay. Anyway, so all of these are DLLs from Vista. We have implemented everything we need to run these DLLs. And so now our live CD boots up with this capability. So what is next? The next problem we need to solve is cleaning up some of the code that was inside DXG kernel. And so in order to make it into a mergeable state, we have to take this empty guy, which is entirely empty. Well, not really, but it's mostly empty. And make it do the magical thing, which is pretty cool. Mr. Fire is on a mission. Yeah, I am. A mission to not lose my shit. Okay, so that looks good. That looks good. Boot-a-doo. Okay. Let us grab our good code. Or, sorry, the other thing that we need to do, maybe, is another alternative we can make to doing this is seeing about loading this properly. So Vista DXG kernel. The reason I haven't been doing that up till now is that in order to do that, we need to basically go in and grab a bunch of my MSI code, which isn't very good. So essentially what I'm saying is that there's a couple things it's 10 p.m. I don't know why I'm staying up late to do this. I probably shouldn't. So enjoy my whatever the fuck this is. So we need to grab these specialized funky wonkies, which I actually probably have implementations to most of them. Yeah. Oh, that's if we want to load. We're doing this Europeans a service. I do not stream on the European time very much. That's true. So these ZW functions are both user mode and kernel. I know that. I'm not really sure why this driver feels the necessary to do that like this. It's a little obnoxious. So I can load this. Try and load this. If I do that, I think I know where it'll fail. And it will fail inside the MSI interrupts. Or we can, instead of trying to do it like that, we could mark, we could try and allocate just something to dispatch them by hand, like a route, and then load it that way. Do I want to try and pursue putting all the pipes in place or putting my code that I wrote already in there? I think I want to do all of the pipes. And I say that because if I do it right, I should be able to just invoke the CDD service, grab the display, and try it out with that. But I don't really think it will get us that far. DirectX doesn't kill GPUs that I do. Yeah, he came to my house and beat it up. That's a true story without any lies at all. Yeah. I think I want to grab and clean up my code. I think that I've spent a lot of time researching these interfaces now, and that as I start to copy it over, I will probably find crap I don't like, and I think it's time to rewrite some of it. If I do that, I can start designing the classes I need to in order to invoke and keep track of the vidpin network, which my implementation for isn't what we're going to grab today, but I wanted to start designing, because I'm going to redo that part entirely, basically. The reason being is because the video presentation network in Vista and every other version of Windows later basically is entirely, it can entirely write to the display isolated of what Win32k is doing, and I never considered that. And so I want to write API test cases built into the XG kernel that will invoke the other displays and force my RTX card to display on other things, along with my my VirtualBox card. So putting it all together, I've gotten it to do basic things, but I think what today we're going to do then is just clean up things as we go. I really think that's the only right option. Yeah. I just read the Twitch activity. What the fuck? Anyway, I'm gonna ignore that. I think I know who that is, actually. Anyway, so, right, we're gonna rewrite this. We're gonna do it quickly. Well, we're not gonna do it quickly, but we're gonna start it tonight. And in fact, here let's throw up our goals. Yeah, that's a good idea. Okay, I'm gonna make a log in my DXG kernel, my cool fucking log. Right, marked down because it's even cooler. This shit. Lick DXG kernel. RDDM. There we go. This is incredibly important. This is the most important thing I've done all week. I forgot how to write. Okay, so our goal for today. I want to end, before 12 a.m. Yeah? Yeah? Okay. End before 12 a.m. I want this implemented. Okay, cool. Now I can feel special about myself, because if I don't brain it, it won't get brawned. Okay. Okay, I'm serious now. Serious. Ready. Oh shit. Ah, fuck. Okay. Alright. So, RxGK mini port. If we go back in here and we go into KMT, we go into this, we go into Win32 Vista, and we go here. We have all of the different source code for the different variants of the code I've done. I'm serious, this thing is like almost 300,000 lines long. Doesn't look like it, does it though? Okay, so here is the old DXG kernel. This is the one that can actually do basic stuff. This is also the one that has killed every graphics card that I've tried at it. Very scary. Okay, so after that we have DXG kernel new. This was my attempt at trying to clean up some of this code. Didn't exactly end up like I wanted it to, but it's a lot closer. Now we have here, create the device. I'm gonna change that really quick to be the right version, because if I don't, it's going to make me very, very sad. I don't like to be sad. That would be unfortunate. Where, where is it? DDK, D3, DDR. Let's grab Vista. Okay. Cool. So, initialize mini port is the first transaction. Please don't copy the entire thing. There we go. Put in there. It's actually, I think in Windows it's called DXGK mini port, initialize mini port. I'm actually not 100% sure about that. But anyway, I know that some of this is fine as is. Get rid of that. We'll get rid of that. Status. Put that there. Put that there. So when we allocate a driver object extension, it's the size of the private DXG kernel extension. This still exists, kind of. But if we look at it here, where is it? Here it is. So RxGK private extension. The way, hi Marcino, what's up? The way this works. Oh man, that is not what I want. Actually, it has been very cool. Okay, so we have miniport PDO, miniport FDO, the driver object, the adapter interface type, the miniport context, a registry path, a new registry path, because this is based off of some of the miniport logic, and I'm not going to change that because I wanted it to be the same on purpose. System I/O slot and bus. This can be ACPI or PCI. As far as I know, that's all that actually is supported by even Windows 10 at this point. So, ACPI or PCI. Currently, we probably should grab a couple of the exports we're going to want to right away use. What I mean by that is if we go up here and we find disport, I don't know, we can grab the functions here. I want to grab all of these. These functions are the basis of pretty much a lot of this. They are the most important. So let's go ahead and just grab these. So we have driver data, driver PFNs, these function pointers, that will be relevant. Do we want to actually keep track of the version? Probably, because if I don't want to. One thing that modern DXG kernel does that I don't like is that if the version's not right, it won't. It'll hate you. I do this kind of here. However, I'm going to do it a little differently. So I still want this to be public. I think I want it to be public. Yeah, I'll keep it as a pointer. So RxGK driver extension RxGK. This, I'm probably not going to change this very much from what's actually here. If you look closely, you'll notice that this is like very close to each other. Yeah, there's a reason for that. Anyway, so just grabbing these for now. I'll switch it to the new naming scheme because I want to feel better about myself because I'm evil. Yes, feel my ego. We'll call it that. Sure. Nah, we'll keep it like that. So that way we'll know what's different between what is private to the WDDM stack that we created and what is public to the WDDM stack interface that exists between public information. So we're going to allocate a driver extension now, make it the size of whatever the frick, be that, grab that, point to that, that will do that. This is now as good as it was. I'll allocate that. To finalize initialization fills out all of the dispatches in question, and that's still probably the case. I don't really see why I need to keep it in separate functions, so I'm not going to do that. We have p driver extension, driver extend. HTML driver object, we pass it in all of the mini port dispatches, and then it will finalize its initialization and return success. So we are going to do that too, pretty much. Return this, return success, return status. I'm going to change the name here because I don't like this. All of that is fine. DXGP extension doesn't really make any sense, right? Because it's this. Oops. This is still here, I recall. Mini core driver object. 1 year, just quick. Just quick. I mean, I don't think I'm doing it super quick. No, actually, maybe I'm pretty fast. I've been doing this for a little bit. I think I started like, oh man. I don't even know when I started, actually. It was a long time ago. Oh man. Got me thinking now. That's weird. Okay. Do we need this? I don't think we do. Yeah, we'll keep it the same. That's fine. I don't really want to change it. Internal device number. Yeah, I was indexing that, I think, and I wanted to keep track of how many devices are getting enumerated by DXG kernel. So my thought was, ooh, this year's gone by so fast. Yeah, it has. Oh, man, maybe if I actually just... No, I don't... Fine, we'll keep it. I actually still want to do that, I think. So, now we have all this information here. If we go in here, we still have these. We should do this. I want to grab the version from the driver init data. Version equals driver init data version. The print RDDM. WDDM mini port driver reports a version of %x. In this case, we'll grab it from here, grab it there, version there. We know that we want to do these. So these dispatches, we have dispatch all this. So I'm going to create a dispatch.c++, rxgk dispatch.c++. It's going to be the same thing. Grab that, do that, grab that, rxg kernel, grab that. Holy shit, hello. Good morning, good evening, good afternoon, good night. I'm tired. I said I'm going to do one interface. Anyways, nice progress. Keep going on. Thank you. So, I know that these functions exist here inside miniport, but I don't like that. So, we're going to change them up a little bit. RxGK dispatch, RxGK port, RxGK port dispatch. My naming scheme's very strong. This also isn't at all close to what Windows is naming these internally. So you might be curious, Dark, why the fuck are you doing it like this? I just didn't really want to deal with the way Windows does this. I am going to come back to this one in a bit. I feel like the way Windows did this was kind of silly. Do I have a DXG kernel interface yet? No, I haven't even initialized that yet. So let's just do this. So we'll grab that, grab that, grab that, then we'll do that. We'll find where these are in the headers. RxG port, driver and load, RxG port. Cool. Yay, okay. So that's there now. Now if we go in here and we switch the names around. Okay, so what did we practically do? Where am I missing unload? Yeah, no, it's just being silly. Ooh, let's not do that. So there's dispatch now. This calls the mini port callback. These, I have a pretty good idea of what they do, but they are not inherently useful for now. So eventually they will be, though. So this is my third time redoing this from scratch, by the way, in case you're curious. It is probably going to be the last time. I was willing to do it so many times because every time I redid it, it got like 10 times better. So my understanding of it's a lot better than it was, and I don't want to leave ReactOS with something that barely works. So I got over that hump of painful rewrites. Basically. Oh, you know what? That's not what I meant. I don't know why I said bin interface. I wanted the start adapter interface started. Okay, so pretty much these are all good now. If we tried to call this, what would end up happening is that add device would be good. Let's actually watch. Let's just get this VM set up. Weep, weep. So we have all this stuff now. Let me do this. So I'm just gonna get rid of that. It's annoying me for some reason. USB, yep. SVGA, yep. Audio, yep. Network, yep. Pipe, good. Let's go with wiping of that. All good, all good. Okay, let's fire up this. So we'll completely clean a fresh boot CD. And then we'll only build DXG kernel, so our symbols are correct, which is unfortunately important. Just need the DXG kernel so I have that in history. Okay. Need WDDM, boot CD, go ahead and fire this up. Let's go ahead and load the modern tools. There is, I promise, a relevant reason to why I'm using this version of VirtualBox, and it's because it's a lot better for Vista, and because we are switching to a Vista version of the stack. Okay, well, we're switching to Windows 10's WDDM stack. However, it's going to act like Vista at first. So, because I think that is the right move. All right. More people realize that Vista is is the most important there is and will ever be. Yeah, I am very glad VirtualBox fixed that. Vista's like the foundation to everything that made modern Windows what it is. It's important to me. But, you know, we're cleaning up code today, Win32. Everything I'm doing today will actually be sent into a PR. It all went downhill from there. No, it didn't. That's a meme. I've seen every person that is like, oh, it went downhill from... I went downhill from 8. 8 was great. 8.1 was great. It's just the user interface started sucking. And then 10 was like, meh. And then 11's kind of struggling. But 8... internally, like outside of the user interface, man, beta 8's amazing. Like outside of the user interface, 8's amazing. Oof. Downhill, like. Oh, right. Do I feel like trying to recompile this as Vista right now? Nah. Yeah, I know. There's a lot of stuff in 8 that we need to go in and... Okay. ReactOS actually has some of that, apparently, or he's getting it. I don't know what he said he was going to do, but... still, it's gonna be take time. A lot of it. Okay. Management. Still, with any luck, I think that ReactOS will function a little. Just a little bit. Either way, I don't know. I mean, we've been saying it'll get better for a while, but there's been so much work lately, I genuinely think so. I'm gonna change this really quick. Okay. Let us see what crazy cool changes we've made. Then I'm going to go a little faster because I don't really want to do this for too late. But I want to get this skeleton, I want to like build out more of this skeleton so I can have that code getting ready to get reviewed. Okay. Yeah, so if you look at, right, that's not what you need to do. If you look at the log here, it loads the WDDM driver, it loads DXG kernel, prints out this ReactOS display marker flag thing, talks about its version, creates the device, talks about what it reports, which the driver reports a requirement to Vista SP1, doesn't actually mean anything. And then the mini port finishes. If we tried to load this, the funny thing is nothing's going to happen. If you notice, it's just gonna boot anyway. So this bug check means that it doesn't have a video driver because ReactOS doesn't fall back to VGA right now. But yeah, so if you notice, it didn't really do anything after that. It just was like, yeah, you know, I'm gonna boot anyway. The reason for that is because the way DXG kernel works, after add device's success, basically after it finishes, the mini port driver doesn't do anything else until Win32k loads. And then it has to make an IO control that invokes the start, which is actually done with Watchdog, but we're gonna hack it because if we don't have Watchdog, and I don't feel like making Watchdog. Technically, for the memes, I could inject the Vista one and that would work, but I'm not going to do that. So, okay, so what does this add device really do? Here's my old implementation of it. It's kind of just shit right now. It was just testing a lot of things, but we can kind of put a couple things into consistency here. So if we put this here, failed or something, wrong parameters, I don't know. Is it bull crap? Yep, it does. So this obviously calls the mini port routine, and in fact, if I did this with context, this would actually do something. Let me show you, I guess. So we'll create status. I'll have to debug break back because I'm going to test this really quick. Put status here. Put that there. We'll grab the context again, which is just a pointer. Keep it separate for now. So we call it with physical device object and context. If this gets called like this, it goes back into the mini port driver, makes its first invocation. Oops. This invocation is the first thing that our DXG kernel oh, wow, that was weird. That was really weird. This is the first thing that our DXG kernel tells the mini port driver to do. The problem is that it's not super interesting. Hang on. Let me just grab the right thing. Wee. We don't need that anymore, or that. Just grab that. Going in here, driver, not that. My bad. ReactX, DXG kernel, kernel.sys. We can undo that. And then we'll see what crazy magical things will happen. It's not that interesting, but I'll show it anyway. But I've shown it before, I think. Well, maybe not on stream, but I've definitely taken pictures of it, talked to it before. Yeah, you can't really see anything because we're not actually missing any functions. But there you go. It called something from the mini port. Whoa. But yeah, we're not missing any functions, so it doesn't fail at all. Also, I think VirtualBox's driver there just allocates something crap, and that's it. So one thing I was doing was grabbing one thing I was basically doing here was creating the device here a lot like what a lot like how VideoPort would do it. The way Windows does this is with its own class, I think. I don't really care. Changes every Windows version. I don't really care to match exactly what one-to-one what it's doing, and I'm still not going to care. So we need to, the TLDR it, we need to do a couple things. Obviously we call this, that's done. Create a name for the device, create the device. It's a child of the parent device, which is DXG kernel. Filling out these information, grabbing the slot PCI number, which in this case is useful so we can actually invocate the PCI bus and talk to it. Once that is finished, it will go in and attach the device stack, create the registry path. We'll call this import map device link, which is a function that exists here. This, as you can see, is huge and very complicated and has not changed since Windows 2000 at all. Yeah. So we're keeping with that, we're not gonna change it either. This code comes from VideoPort. As you can see, literally. And yeah, it's not going to change, Buckaroo. Is there any DXGK kernel? Okay. Private extension, device extension, which has all of this information. Really great stuff. I don't know why I named it this originally. We can still do that. I am not going to be clever with it. I'm just copying and pasting it as is. This thing works. It works perfectly. Even on Windows. So, yeah. Pretty much. Ooh. I believe that I have been requested for review on something very interesting. Yes. Very interesting. Cool. That is not what I wanted to open. Thanks, though. Anyway, so this code literally just creates the key that we need. It's not that interesting, but it's also incredibly important for what we're doing. So anyway, we're going to grab the changes I made to here, put it in our XGK port. That's why I kept the name, by the way, is because I wanted it to be like, this has not changed at all in decades. Also just to fuck with people. So, going back here, we know what the mini port context is. This is not necessary at all, actually. We can go in here, go in dispatch. Okay, hooray, we found the thing. Good job. RxGK driver extension. IO status block information. And yeah, cool. So, we have the FDO. We have an IO, the device name and buffer, and IO status block. If we call and look at other places where IO create device is called, like, you know, video port, it's, you know, I don't actually need to pass anything for this, do I? I don't know what I'm trying to. Yeah, whatever. Device name, FDO, am I missing anything? Oh, yeah. Cool. That's create device. And we can actually just identify that. A video device. We actually don't need to do this at all. This makes sense. And create registry path, which probably should be in here. And create IDs should be in here. What is this for again? Which is in resources. Yes. I remember. I was trying to keep the code separate. There's no reason to do that. So, this is no longer necessary, right? Create a new registry path. Yeah, no, that's good. This is good. I'm seriously not changing this at all. That was weird. Cool. That's done, that's done, that's done. IO create device. We're gonna assign private data here, and then we're going to do it like this. I'm gonna keep it up top just for now. So, one thing you probably noticed. This will allow us to figure out what our interface type is. So the TLDR here is figure out our bus, figure out our device, After all of that is done, we can go ahead. Do I need the deferred routine still? I don't even remember. Any port context, DPI routine. Oh, yeah, I remember that. Sure, we'll keep it that way. I'm not gonna want it that way forever, but it does make some sense. It does make some sense, actually. Going back down here. Yep, so just create the new keys. So yeah, this part's probably kind of boring, but so set new video math keys. Yeah, that's fine. We need the name. I'm gonna clean this out a little bit because I don't like these prints. Driver tag success. Just set up success. I don't know why I'm doing 2. And then this doesn't need to be print 1 anymore. What happened to Panfrost? What happened to Panfrost? I don't. It's called Panthor now, and not much. I still work on it pretty frequently. More now that I'm reaching the end of my understanding of this. I really went into that, and I don't think I understood as much as I thought I did. So, nothing. That's going to continue here soon. I will probably even stream it because I'm hitting the end of the remaining opcodes now. So, D3D10 almost works, basically, is the layman's term of that. But nothing really. I'm just really bad at working on one thing and all the way to the end, and I like to bounce back and forth, but I usually end up finishing things, so it works. This is creation successful. Yeah, these, I will say though, that Panfrost and this kind of bounce each other off a lot, where I'll work on this, learn something more, and then I'll work on that and learn something more, but not people really haven't created an open source video driver for Windows fully, so it's been fun. Okay, thanks. Yeah, no problem. Yeah, TLDR nothing. Nothing bad happened to it. I'm still doing it. DPC object. Right. I need a DPC to keep track of my magical funny things. I also would like to keep track if this gets called. So I'm going to DXG kernel entry and then done. Okay. Yeah, I don't need this. Okay. Unresolved external. Oh. There we go. Let's see. How are we doing? Well, nothing looks broken yet, so I guess it's pretty good. We are at 11:55, and we have cleaned up the add adapter routine. I don't think I'm missing anything else. I would like to maybe go through this and just change things around a little bit, because some of it's not even necessary anymore. We don't need the legacy key. That's not even a required thing for this, but I was trying to keep it identical because it's the same end result. And I was trying to be clever and reduce code. But we'll see. So going back in here, going back in there, we can do this. And now, if we do this, what will happen should be not super anything, I don't think. Yeah, that should work. Okay, so if we go back up here and we look at when it loads, we will see a lot of very interesting things. The device number being 2, the interface type being 5, function number being 0, and create IDs being success. Interface type. Five is PCI. 5 is PCI, has to be PCI. Five is PCI. Okay. That's good. What device number? I kind of wanted the ID. Oh, you know what? That's for invocation. Never mind. That's separate things, actually. I'm silly. Okay, that's still good. Just move this back up here. Move this there. Okay, I think we're about done with that. So, okay, that is the first step here. Git add, git commit, dxg kernel, create the add device routine. Okay, so now we have to decide how we want to get everything in the right spot. So, let's see. So what I've been doing is making it so there was a Win32k API that basically initializes the DXG kernel. So I called it DXG kernel hacks. This is how Windows does it. This is my idea. So I created a custom IO control that gets adapted by what the Vista thing by what it's doing. So the plan was, if I could use this IO control, I could figure out what is okay, sorry, my brain's frying. I can figure out what is what, basically, and if something fails where it's like, okay, it's not going to work, I can call this function and try and trigger the Windows variant. So this try start adapter thing was in here, and it will call that as a fallback. So that's fine. Yeah, that's fine. However, my problem with it in the past was, in order for this to work properly, we'd have to have Watchdog there for the Vista one. But there isn't really a way otherwise. God, this is so fucking wild. Yeah, there's no better way. So let's say that this is, I'm still gonna name it this. I don't want to change the name of that. I think that would be kind of meh. We'll also have these. This is going to be unimplemented for now. And this literally just... Wait. Oh, right. I know why it's working like that. Shit. See, that's why I wanted to redo this. So, let me give you an explanation. Vista, when it starts up, it doesn't render anything anymore, except for on a new session. So the initial session loads a driver called TSDD or whatever, which is literally the disconnected driver. So, basically, what's happened here is this function is something that exists in Vista to notify when the session changed and change states for basically when that thing starts happening. So when logon starts to fade into the desktop, basically. So if I were to do this right, this would not be like this. So I can't do it right for that yet. So let's do it like this. I want to still track this. So implemented. So this way, what's happening now is that we're going to call this try start adapter, and if it fails, yeah, we'll know. We'll also have is WDDM on still being the thing. So if this is true and equal to true, it'll do that. Else, it's just something went weird. As for this, let me grab it. We have RDDM file object, RDDM device object. I'm going to keep it as that naming scheme. Just for now, we'll have this IO control here. It will exist inside the SDK, which will exist inside ReactOS. RDDM, RDDM private. ReactOS, DXG kernel trigger. And then this up here can still try and do that thing. So this goes here, that goes there. RDDM private interface. Then we're also going to have RDDM private. That will get that. That will be there. Then we will have our device object. We will go send the IO control. If the IO status block isn't equal to success, we know it's Windows DXG kernel, and then thereby we will start up with this. This is where things get weird. So, else, or sorry, if WDDM is on, we'll do this. And we know, ooh, this is interesting because, or wait, hold on. This will trigger, or the adapter failed. I'm going to return the status over it. So WDDM is on. Deep print. ReactOS. Display. Driver model. TK start. Started, so we know that the adapter is started, so if this has happened, there's nothing else we can do right now. So stop the OS. Beyond that, I think that's fine. I don't like a lot of the names here, so let me clean this up a little bit. So first off, attempting to see if this is Windows DXG kernel. Probably don't need to do that much. Putting out control with DXG kernel. Kernel status. Or the adapter failed. Hack triggered. So we know that we start with the ReactOS DXG kernel. Okay, start, and the adapter started. Okay, so that will work now. If we grab, if we grab this, and then we do this, we can grab this. We shouldn't need 132K for the rest of the night. If we, so let me look at this again. So if WDDM is on, otherwise SS is not equal to success. WDDM is true, but that is false. Return false. Let's not do that. Wait. Sorry. Let's change this around a little one more time. WDDM is true, so it was attempted. That's fine. Shit. Yeah, you know what? It's fine, as it is. Okay. I am ReactOS. Going back in here, going back into entry, case. Same thing, pretty much. Difference being that the status is equal to... what the fuck? Why am I doing that? RxGK, start adapter. Start adapter, yeah. Or yeah, actually, hang on. TAPI, RxGK, start adapter. Implemented, debug break. Put that there, put that there. This should be called like this. After that, the IRP is complete. So if we return status unsuccessful, we should know. Going back up here into the KMT, if that actually happens, it's the adapter, it failed. Adapter started. Adapter failed to start. I want to put some things in here. Okay. Win32K, DXG kernel. Let's throw this into place. Give it a shot. So what did I do? I essentially created a just a custom IO control that its only purpose is to trigger the start of this. That's pretty much it. Yeah, that's pretty much it. Not much else to it. So now when we load this, and we load this, we'll see when we want start the trigger, or we're going to have a file system error. Yeah, I kept restarting it and slamming it. Here, let's just fix it. Let me check disk. I really need to get a version of check disk that works on ROS properly. I don't know why I keep doing this to myself. Scan and fix. Repair drive. Repaired. Okay, so now we will boot all the way to the operating system, and we can see that the adapter supposedly starts. Now, I have no idea what this is. I actually don't. What the fuck? No. Not. That should be good. Oh, yeah. Okay. That will do it. Whoops. Okay. Hang on. I'm like, what? What? What could possibly be talking to it? There's nothing else in here. I'll talk to it. That was funny. Yeah, there's... That was funny. Cool. All right, so that now works. As you can see, after this I/O control is built, we hit this start adapter, which means that now we can actually, start the adapter. If the operating system tries to continue, we know that the adapter failed, and the adapter failed to start, which then would be like, all right, this is failing. Yeah. In fact, I probably should make this as an else if. That was my bad. But that's the idea. The plan here is that the operating system will continue booting up if the adapter fails, and then now we have a way to actually make sure that the adapter ever gets its communication that it's looking for. Yeah. Here. There you go. And then XG kernel, okay, cool. So, okay, everything so far probably seems pretty stupid that I'm rewriting it, but if I don't do this, I don't see it happening again. So this is our chance to clean things up as we go. The idea here is that there are two subsystem, SDK, and DXG kernel. Create a start adapter trigger. This is custom to us. I will implement the real one eventually, not today. Not anytime soon. I know how it works, and now I know more of how it works, actually. It's kind of funny. But, yeah. Okay, let us implement this now. So what does start adapter do? So as you can imagine, it's the biggest trigger in the entire thing. So DXG kernel has multiple subsystems. It has a device subsystem, it has a vidpin subsystem, it has a scheduler subsystem, a memory manager subsystem, and a couple other things that have been added over the years. What we need to do is to make sure that DXG kernel is capable of obtaining the resource information for the device in question. And so what will happen is that we will basically enumerate interrupts for the thing. and get it tired. And get the start adapter to trigger and work. So okay. Now, this is a nasty function. Okay? It is incredibly nasty. It doesn't look like it, I know, but it is. So, this bus can be hard-coded. That's fine. I'm going to keep it doing that. So, let's go through what needs to be. This is the reason, by the way, that in our my cool log we have one interface ported over, only one. You're gonna see. So we have the DXG kernel interface, the start info interface, the GXG kernel interface goes in here, and it has all of these. And these don't look too bad. We have the ACPI interface, the PCI interface, the read device space interface, basically, the vidpin interface, the monitor interface, the adapter interface. So it adds up a lot. Very much so. All I want is to implement one. We're not going to start it today. But what happens when we go in here and we try and call it anyway? It seems stupid because it is dumb, and it's very stupid, but we're going to try it. I know what happens, but I want to put this in place. So, we have a couple phases. Acquire, start info, information. This is going to be initialized here. Another thing you might be wondering is, why am I using C++ but programming it like C? The reason is everything we've done so far is a direct export. It's all getting put into classes beyond this, basically. So it's kind of nasty. We have the start info interface. We have the DXG kernel callbacks. Calling start adapter. Interrupt routine information. And all of these have to be done. Status is going to be status. Yeah, I'm just gonna leave that. This gets called based off the driver extension. Start adapter. Start device. We have the mini port device context, which, as we talked about, it's in there. So, mini port context. Ooh. We have a reference to DXGK start info, which probably could be a pointer in the first place. Right? Yeah. Wait. We have the interface, which we're going to leave as null for now. And then we have the number of sources. So these need to be created. Adapter.
watch this. So, as we talked about, adapter, sorry. So adapter number of video present sources and adapter number of children, both taking a reference to. Hello, good evening, good morning, good whatever you're doing. Deprint. Returned with status %x. Status. There we go. So, yeah, this is really complicated. The first goofy thing you might notice here, for some reason, this is dependent on getting returned. Why? I don't know. This just comes out. Yeah, this is just a thing. Hang on, I'll show you. So, we have the interface, the start info. Inside this is 5 other interfaces, at least, depending on which version of Windows you're targeting. And then out comes the amount of children and present sources. So you might be forgiven if you think that number of children is referring to monitors and sources was referring to like virtual desktops or something. No. Children over the GPU. Things can be connected over the graphics card. And WDDM supports that. That's crap like the HD audio bus over HDMI. It's crap like I2C if it wants to be I2C. Anything can hook into this and act as a child to the device. It's like the most obnoxious thing in the entire world. I can't even really. Anyway. Okay. So. Now. This will technically call. Technically. But what's going to happen is that the VirtualBox adapter is going to make into this interface. So we first have to figure something out for this. But then start info needs to be filled. And you might be wondering, what is start info? What are they going to do? It's a GUI. It's a GUI. Anyway. Oh man, we're crashing. We're crashing. Oh. I'm so sleepy. Okay, let's start by doing the most basic possible thing, which is the interface. The DXG kernel interface is big. This is the new one, so this is the cleaned up variant, but it's big. Yeah. So let's do this. Extern RGX, you know, RxGK, DX kernel interface, so the ReactOS version of it. Or I guess I could actually just make it a version of this. You know what? Yeah, let's do it. And then we're gonna have not mini port. No. We're going to have device. DXG current, or how about RxGK? Yeah, let's just call it that. DXG kernel interface. And this is where the funny C++ starts. Because here we start getting into the real thing. Okay, the first thing we need is to go into here, go into there, go into this, go into that, do this, get that. And then we can start just filling this out. So the way I did this originally, it was creating a function that ends up setting up the DXG kernel interface. I think I'm going to still do that. So let's do it like that. Everything here goes there, everything there goes here. Notify DPC, everything ends at adapter access. So we're going to end at adapter access for now. All of this can go away. I don't see why that would be done like this. I don't know what I was doing. I'm not going to report that. I'm going to report Vista. Yeah, let's Vista SB1. That's fine. Right? I think? Yes. Wait. Yeah, I think. Nah, let's just do Vista. Okay, so this is the DXG kernel interface driver object handle. These are all of our juicy APIs. This is useless right now. That's fine. We'll do that like this. There we go. DXG kernel has started. No, it hasn't. Shut the fuck up. RxGKP, set up DXG kernel. We're going to put that in here. And this is going to be the last port thing we create. This is going to end up calling a bunch of magical C++ classes. This also is going to be done in entry. Anyway, if we f0 this and then indiff that, we can build this, which now has the interface. This can go in here, right? Nope, actually. Device, DXG kernel interface, .c++. I don't believe I actually spelt that right. I did. Whoa. We don't need this right now. I don't know why I did put that there. We can pass in the DXG kernel interface, which I think is passed in through the pointer, right? Yeah, pointer. So this will now actually start to pass and do funny things. So if we go in here and we go into our interface, we can start grabbing some of these. I could keep it the name schemes, but you know what, sure. As you could probably see, this should be the same. Probably. I don't actually remember offhand if I did that right. I started to. Wow. Maybe I am good at this. Yes. Get DXG kerneled. So these start as C exports, C style exports, but they're actually going to be C++ classes. And we're going to name this class called DXG kernel device. Oh, genius, I know. Absolutely frightening. By the way, we'll probably start doing this today. I don't really think... Yep. Bye-bye. Isn't the map memory funny? It's almost like that's it, and what it does. Yeah, it's one of the only functions in here that actually does what it says it does. Oh, here's something cute. Each one of these are services, entire interfaces. Yeah. Yeah, you don't... There's an AGP service. I don't know what to do with that. You might be wondering why the thing I'm copying from is empty. This was a previous version of the same rewrite, and it only supported PCI and a single device. I'm serious that I've done this like 3 times now. But it's worth it. It keeps my brain in order. Because I don't like how the way I did some of these things. This is where it starts to diverge pretty hard, I think. Chances of me keeping it the same aren't very high. Also, I don't... Yeah, hang on. I also made my own headers, which changes things. Kind of. A little bit. Just a tiny bit. This also isn't... Yeah. Was it const? Oh, I don't even remember. Yeah. I don't need that. That's just dumb. Isn't it cute, the stupid thing? Oh. This is a whole other interface, by the way, just so you know. Just pretty much everything out with an out pointer is an entire interface. That's just chilling. Was it const? I don't remember. Ah. Annoying me. I hope that knowledge makes your day a little worse. No, I'm kidding. I think. Ooh, am I really giving it that? No, I'm not doing that anymore. Exclusive adapter access. Yeah, that's fine. Okay. That's not... It's not right, but okay. Also, same thing. Wow, what is that for? Stop. Literally this. Seriously. What am I doing with my life? I was a happier person when I wasn't doing this. I don't know why it's like that. Am I missing some? Probably not. This just makes me so mad. I don't want to deal with that. Oh, hang on. Duh. That's why. I'm like, what am I doing? Because I wanted to be special, make things more complicated. Kind of. Just a little bit. Oops. Right, so this is all wrong. I know that. It has to be done like this because of that. Yeah, no, that's wrong too. I know. Look at me. So fucking perfect. DXGK callback queue notice. Callback notify routine. And that can also be yeah. That's actually fine as it is. I know what I was trying to do there. Also, okay. It's not how that works, but okay. Notify interrupt. What a boof, boof, boof. Oh, here's funny. Here's something really funny. Watch. Yeah, same thing, by the way. Yeah, that's my life right now. Read device space and write device space is cute. Probably fine as is. I don't think I need to do anything there. Make sure, because I don't really remember. Config. Yeah, we can add that in. It's fine. Let's say this. Okay. As you can see, these functions aren't very complicated, but that's what they do is all. They're callbacks and the different types of spaces that could be read and write. And yeah, they're not super interesting, I guess. Bus interface probably needs to be set up, I guess. Yeah. Because if that's in here, I know that's in here. Okay. We're almost done. as you can see, some of these are just wrong. Yeah. Yeah. That makes sense, actually. The vid pin's also wrong. That's interesting. Let me grab it. Don't really need that anymore. Don't need that. That one would do. Whee! Okay, and then query monitor interface. I'll grab that. And then now I can keep track of things a little easier because it's actually sane. Hooray! Okay. Okay. Now I know that's PCI, so let me try to do that really quick. This query interface thing is, yeah. I'm gonna keep it as is, actually. I don't know why I did that, but I'm gonna call it RxG. Oh, yeah, look at that. Wow, maybe I'm, wow. Wow. RxGP, beep, 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 beep. So that will actually call the child device. That can go in mini port. This will now initialize the thing properly. So this, what this function did is try to initialize a thing. Hang on. RxGKP initialize PCI. If you do it like this, status. Yeah, I can return status, that's fine. Return status. Get the extension. RxGP, query the interface. Need the bus. This is the PCI bus. That will initialize PCI. If the driver extension dot interface level bus interface internal device number adapter interface type is equal to PCI bus, then go ahead and call that and make status equal to that. Or actually, let's do it like this. Sorry. It's equal to that. Okay. That could be a switch statement. I'm not going to make a switch statement right now. Must return a value. Cool. It's done. Okay. Yeah. Hang on. I forgot to stop the OS, but as you can see, it creates the device with context, and then RGK device callback gets called. It returns the status with status unsuccessful, which makes sense because this callback literally failed, right? This is the callback it's talking about, and this is the opcode or the return to code. It's literally what it returned. That's not, it doesn't take a genius to figure that out. But so let's try this. Let me make sure I have my prints in order. Print1, initializing bus communication. Calling mini port start adapter. Okay, so start adapter is getting called now. The interface is being passed, and the first callback from our new interface is being triggered, which is device information. And if you've done video drivers before for Windows, this is the thing that you call if you want to get the resource list. It is actually very simple. This new PCI function exists now, so we can actually initialize our adapter callbacks, and yeah, it's good, cool. It's done. That part. So basically, it's just create the DXG kernel interface. We didn't do anything. We created one interface, basically, the parent one. And yeah, I mean, yeah, anyway, that code's pretty much ready to be looked at. That's why I'm doing this. So if you're curious, we have completed every goal. Congratulations. Oh my god, Kit. So when adapter is finished, the enumeration interfaces port are over, initial import's done. So that's the start. That is the start of the cleaned up version of DXG kernel, which I will start giving to people to look at. So thank you all for watching. I'm going to end it here as I promised. We'll do it again tomorrow. Thank you for watching. Have a good day. Bye-bye.